Hi, welcome starting. Our app's name is Route Notes. Have you ever had this happen? You want to plan a road trip or a bike route for your friends, but everything quickly becomes a headache. Maybe you are trying to visit several places, but it's hard to find the restaurants or bars you really like at each stop. So you just keep switching between different apps to check addresses, reviews, and routes. Sometimes you finally pick a few locations, but the plan changes later and you have to redo everything again. Or maybe you arrive in an unfamiliar place and want to find an Instagrammable cafe that sells donuts. Since your request is pretty specific, it's hard to find exactly what you want on Google Maps. So you might scroll forever, checking photo after photo, and still can't tell which one really fits your vibe. To solve these problems, we designed Route Notes to give users more control and flexibility throughout the entire planning process. We help users create multiple stops to build their own customized routes. Route Notes use AI to generate more detailed and relevant place recommendations, allows users to update their routes plans at any time, and integrates Google Maps to ensure quick and smooth navigation between every destination. Now we will show you our demo.
And so users can log in. We already have an account, so we'll just log in, sign in. And because this app needs user locations, we will be requiring permissions from it. So we'll set yes. And so what a user can do is that if they are going in between places a lot, so we can go to the settings, common locations, and say that they are going to college a lot. So let's say Langara. Using Google Places autocomplete, we don't actually have to worry about getting the specific location. Google Places autocomplete will do it for us as it gives us the location. Save location. We could call it college, and we'll save it. And so we can save all these various different places. We can also delete it if we want. Same thing with common places. If we want, if we frequently visiting different places, we can actually save them there. And so when we want, so say like it's finals, you don't want to study, or you don't want to think as much. You want to go from SFU, you want, I don't know, Chinese food. You walking distance, and you want cheap, but nice. But later on, you're going to be meeting a friend at Metrotown, and we could just do Google Autoplace as well, or autocomplete from here. Say that you want to go to the library. Say it's a library, walking distance, and you want to plug your laptop in. You can ask for advice. And then the AI will give you a response, tell you, Jade Garden Chinese food, SFU. It'll give you tips, and for each stop, if you like it, favorite it, call it, meeting with friends later, save, and then your route will be saved, and you could search if you will have pizza on, and you could save it in there. And then as a little quirk, we have a weather using Open Weather API to let users know what the weather is currently, and if that might influence their route. That's why we added it. And so to visualize this, we used Google Maps preview. We can actually get a preview using Google Directions overview polyline. So Google will actually do the whole polyline for us, and we all just have to decode it. And so if you preview, it'll give you an idea of what the route's going to look like. Press edit. You don't want Jade Garden. Let's say you want Uncle Fatty's at SFU. Google Places, autocomplete places will actually do it for you. Swap it. If you press preview again, it changes. You like it, press go. It'll open up Google Maps, and it'll give you directions. And Google Maps doesn't like having public transport for more than one stop, so it doesn't support it. But, it'll give you cycling or driving.
On the favorite screen, user can edit any saved node. For example, I can rename a node from favorite one to tomorrow. I can also tap edit to open a full editing page. You can see all the information we previously entered. If we want to change the first stop to SFU, I just delete UBC and add SFU. Basically, you can modify anything you want, then tap the Ask AI button. After the AI generates a new response, simply tap down and the new result will replace the old one. Now I will explain our AI calling logic. In this app, the AI starts from the search screen. When you tap Ask AI for advice, the app receives input from the rule node adapter and build a long prompt with prompt builder. Then OpenAI service sends this prompt to OpenAI chat completion API using OKHTTP with your chosen model, temperature, and max tokens from settings. The JSON response is parsed, and the text is posted into live data in search view model. AI Advice Manager observes it and updates the UI to show the AI suggestions.
One of the big things that we run is OKHTTPS, and this is basically what allows us to make API requests. So we use this for chat for the OpenAI API and OpenWeather. And so just as basically we do the same thing that we would usually do, we build a string using this case we're doing we want the polyline from Google Directions, and so using the Google polyline, we don't need to worry about drawing the polyline. It's because Google will do it for us, and all that we need to do is pass in a polyutil, which will decode it for us, and they'll draw the entire polyline for the root. So some of the new things that we brought in that we don't have enough time to go too deeply in is Firebase, which has allowed us to centralize our data and made syncing data amongst users a lot easier and not having to deal with multiple room databases since those are local. Regex, which is something that I've personally used, and some of us have also used in web development and other things, has helped us a lot in parsing data from API responses and being able to use that data for our app. Another thing that we brought in is Google Places autocomplete, and this took the load off of us, and that we don't have to verify locations inputted by the user, and that Google will do that for us. So what did we learn from all this? Work with a multitude of APIs forced us to kind of step back and make sure check how data is moved throughout our app. Collaboration, learn to commit often, make functions clear and have unique names. The MVVM model helped us understand what goes where and where to look. And we ended up going through growing pains with this, as early in the semester we ended up generating a ton of files, and it kind of was like, well, what's the point of all this? But as then the code eventually grew, we realized, okay, if I want to look for database functions to attach to mine, I will look at the repository side of things.
During development, we faced many challenges. One challenge was pulling clean addresses out of long AI replies and showing on the map. At first, the text was mixed with tips and was hard to parse. We fixed it by updating our prompt and telling the model to put each address inside a code block. Then we used our Markdown renderer to render the Markdown and let the user copy the address easily. Those addresses go into the search form and are resolved by Google Places autocomplete. Later, the map screen loads the saved route from Firebase using route repository and map view model, and shows the waypoints with the Google Map SDK and Direction API. In our app, everything the user can see or tap runs on the main UI thread. Activities and fragments such as login, settings, search, map, and all button clicks live on the UI thread and talk to view models from there. When the UI calls into our view models, we start coroutines in view model scope. Some flows begin on the main dispatcher and then rely on a wait or helper service that move the heavy work of the UI thread, while others, like fetch polyline, launch directly with dispatches.io. The expensive work such as network runs in the background. Map view model and manual search fragments use OKHTTP on background thread to fetch Google Directions polyline and place search results, and OpenAI service wrap its OKHTTP client for OpenAI calls. Firebase Author and Firestore also perform their network operations on background thread, and then report the result back to the main thread or to the coroutine that await them. One clear exception is the sign-in and sign-up flows. Their activities call Firebase Author directly from the UI layer instead of going through a view model. But Firebase still does the network work of the main thread and delivers callbacks on the UI thread so the UI stays responsive. Here is our task division. Our project scope fits 5 people because the tasks split into AI search, favorites, maps, settings, and authentication. Each member owns one area and everyone also contributes to testing and documentation, so workloads stay balanced. Thank you for your listening.